Okay, so in continuing with operations with rational expressions, okay, here we have three ratios, okay, that have unlike denominators, but have similar factors. Now, in looking at what we have for the denominators, okay, so if I'm looking for the least common denominator, okay, so we have in these, okay, so you have for the first denominators, they have 9x cubed, y squared, z. And if I draw out 9, factoring out, say, I have 3 times 3, x to the third, y to the second, times z. Now for 15, x squared, y to the third, z. Okay, so I have 3 times 5 times x squared, y to the third, times z, and that should be to the second. And for 25x cubed z, so we have 5 times 5 times x to the third times z. Okay, and if you notice, we have for 9x cubed yz, so we have the factor of 3 is going to repeat. And if I put this repetition in exponential terms, I have 3 squared times x to the third times y to the second times z. Again, for 15, x squared y cubed z, okay, you just had the same thing all over again. Yeah, first order in both 3 and 5. Now for 25x cubed z, okay, 25 is going to be the square of 5, and you have times x to the third times z. All right, now in the case of the least common denominator, okay, this will consist of the highest order degree representations of each factor. So we have the numerical factors, we have 3 and 5. Highest degree expression in 3 we have, among the factorizations will be 3 to the second. For 5, okay, we have no 5. Next denominator we have only 1 5, and as for 25, this will factor out to 5 to the second. And for what we have in the case of x, the highest degree representation from any one of the factorizations we have at third order. As for what we have in y, we got no y term, y to the third, and y squared. So the highest degree representation in factoring y, we have y to the third. And as for z, we've got z to the first, z squared, and z, so we have z to the second. So for the least common denominator, okay, we have 3 to the second times 5 to the second, and we have times x to the third times y to the third times z squared. And so for the least common denominator, okay, so 3 squared is 9, 5 squared is 25, 9 times 25 is 225, and we have x to the third, y to the third, z squared. Now, in taking what we have here, and we have with this particular trio, okay, so if I rewrite in terms of expressing, okay, what we have and rewriting in the context of the least common denominator. Okay, again, least common denominator, we have it 225 x cubed y cubed z squared. So for what we have in the case of the first rational expression, so we have taking 9 into 225. Okay, this will be 25 times. Okay, here we have already the third order in x And now we have y squared into y cubed. That's going to be y. And we have missing 1 degree in z. For the next rational expression, okay, so I have 15 into 225. So this will go 15 times. We have x squared into x cubed, so we have it x. And we already have y to the third, and we already have z squared. As for what we have for 7 over 25 x to the third z. So 25 into 225 goes into it 9 times. And we already have x to the third, but we are missing y to the third altogether. And we have z into z squared. Okay, so we have going z times. And so multiplying out the numerators and denominators. Okay, so we have 2 times 25yz. So we have 50yz. And the denominator, again, should be 225 x to the third, y to the third, z squared. And then we have next 14 times 15x, so we have 210x. You have over 225 x to the third, y to the third, z squared. Then we have 7 times 9 is 63. We have y to the third times z. And for the denominator, we have 225 x to the third, y to the third, z squared. Okay, and so upon combining the numerators, now we have the same denominator. Bit of a redundancy here, but altogether, so you have 50yz plus 210x plus 63 y to the third z. And we have all over 225 x to the third, y to the third, z squared. And that is your final answer for this problem.